To today. Welcome to Mega-Hedge Chemistry Forum. My name is Atan Kubiat Enyeka. This is the second series of hydrocarbons. It's a continuation of the first series. Like I said, this lesson is going to be in series because there are lots, very more that we need to study under this topic. So we are going to continue from where we stopped in the last series. Now, under this, you'll be looking at the aliphatic part of the hydrocarbon. Aliphatic hydrocarbons. And under this aliphatic hydrocarbons, we'll be looking at straight, branched, and condensed. Those are the areas that we are going to be looking at. We are going to be looking at when an organic compound is said to be straight chain, when it is said to be branched, and when it is said to be what? Condensed. Okay, now for us to study this proper, let's look at alkanes, alkenes, and alkynes. Alkanes, alkenes, and alkynes. Now, for us to understand this, the straight chain, before we start writing the chains, the number of carbon atoms, the number of hydrogen atoms that is present in a particular organic compound, we are going to be looking at these three subheadings. Now, here, alkanes have the general molecular formula CnH2n plus 2. And this have the general molecular formula CnH2n. CnH2n. Then this have the general molecular formula CnH2n minus 2. What it means is that, okay, then we have a sign and number. That's n. So for number 1, let's number 1 to 10, 4, 5, 6, 7, 8, 9, and 10. Then a hydrocarbon that has just one carbon atom comes with the name meth. The one that has 2 carbon atoms comes with the name F. The one that has 3 carbon atoms comes with the name pro. 4 comes with the name boost. 5 comes with the name pens. 6 comes with the name hex. 7 hex. 8 ox. 9 non. And 10 dex. Okay. Yes. So the first hydrocarbons, or the first hydrocarbons, whether alkanes, alkenes, alkynes, any of them that are carbon number 1, just like I have mentioned here serially, takes the name meth. Now, if the compound is an alkane, for example, the name will end with A-N-E-S. For example, if it has 1 carbon atom and it's methane, we are going to add A-N-E. That's what it means here. We are going to add A-N-E. This tells you that this is an alkane. That's if at the end of the day, when we use the general molecular formula, we have a methane, for example. Okay. Alright. Okay, yeah. Here, sorry. We have hex here. 6 is hex. And number 7 is hex. Okay. Now let's use this first formula to introduce all the members of the alkanes. Meth, like I said, whenever you see N is a positive whole number. It refers to the number of carbon atoms that methane has or that meth has. So in that case, N is going to be equal to what? 1. Since Met is the first member here. So we will find like this. C, N is what? 1. Multiplied by 1. Of course, you know that C times 1 is CC. Then H, 2 into 1 plus 2. C times 1, you have your C. 2 times 1 here, you have your H2 plus 2. Now have, this will be CH2 plus 2, 4. This is CH4. Now this CH4 is your methane. Methane. In the structural formula, we have, this is your hydrogen, 4 hydrogen surrounding carbon. 4 hydrogen surrounding carbon. Now, this is for methane. Methane, so the name now will now change. We are now going to attach ANES to here. So we now have methane, methane, methane. So we have methane now. This is the structural formula and this is the molecular formula. Molecular formula. And this is your structural formula for methane. Now, for S, A being number 2. So wherever we see N, we are going to put 2, which tells you that F is the hydrocarbon or the organic compound number 2 under alkanes. Like it's arranged serially. It's just like you're the first one, methane is the first one, ethane is the second one, propane is the third bond in your family. So it goes like that, the first order. Methane is going to be the first bond here, and F is the second one. So carbon, the number of carbon atom here, as you go down, will increase. So here, F is carbon number 2. So wherever I see any, I will put 2. So we'll have for ethane, for F, C, C2, H2 into N is what? 2 plus 2. That will now be C2, H, 2 times 2 is what? 4. 4 plus 2, which you have C2, H what? 6. H2, C2, and 6. So in structure, we are going to have this. How many carbon? 2. Yes. Let me also tell you that in organic compounds, there is something we call tetravalency of carbon. Tetravalency of carbon must be obeyed. Whenever you have a carbon atom, that carbon atom must be surrounded by 4 bonds. Tetravalency of carbon atom must be obeyed. Now, also, let me also tell you that all alkanes have single bonds between the carbon to carbon covalent bonds. All alkanes have single covalent bonds between the carbon to carbon compounds. That's what I said earlier. Then, this is the molecular formula for ethane, and this is structural formula for ethane. So here we can now have ANE for ethane. That's for number 2. Then Pro is going to have 3 carbon atoms. So for propane, we have C3 following this formula, H2 into 3 plus 2. So C3 H6 plus 2, which you have C3 H8. So by structure, being that it's an alkane and it's going to have single bond, we have 3 carbon atoms bonded to 8 hydrogen atoms. So you can count that and see if it's up to 8 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it is complete. So this is the structure. This is the structural formula for propane, and this is the molecular formula for propane. Now for butane will be C4. C4 H2 into 4 plus 2. So you now have C4 H2, 4H2, then 2 times 4 is what? 8. 8 plus 2 is what? 10. So let's take it up. So from there, for 10, we have C4H10. How many carbon atoms is there? 4. How many hydrogen? Can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it actually 9? Yes, 10 here. 10 there. All right. So this is your butane. C4H10. Now, as a smart student that you are, you are supposed to see on seeing this, something should recall to your mind. You see the 10 here was CH4. Now, ethane C2H6, meaning there is an increase. The hydrogen is increasing by 2, and the carbon is increasing by what? By 1. By 1. So C4, CH4, C2H6, propane increased by C3H8, and butane C4H8. So there is a difference in this. There's a difference in this. That is what difference about CH2. This we are going to talk about when we're talking about, like I said, keep following us in series. We are going to talk about this difference, how it came about. Okay. Then for pentane will be C5, carbon number 5 here. So C5 H2 into 5 plus 2. That will be C5. 2 times 5 is what? 10. 10 plus 2, 12. H12. Then this by structure you are 1, 2, 3, 4, 5. How many hydrogen? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So I am going to stop here. I'll stop here for now. Let me use this and this, or let me use this to explain the straight, the branch, and the condensed. Now, we have talked about the structural formula for methane, ethane, propane, butane, and pentane. If you look at this is a straight chain. These are the straight chain. These are the straight chain. These are the straight chain. Now, the branch is, for example, this is your pentane. If we reduce the number of carbon atom here to attach it to the nearest carbon atom, the number of carbon atom here will be shortened from this straight chain. For example, if we have the parent chain or the longest continuous chain, I'm still going to explain what I mean by longest continuous chain. Please keep following us. I will explain. If I have this, if I have this, let me take it down, let me take it up. Okay, let's clean this. Let me take it up so you follow. If we have this, this is 4 carbon atoms, and 4 carbon atom corresponds to our boots. Okay, but if I come here now and I add another C, and I do this, I do this here. I do this here. This is now our branch. One of the carbon atom here have been branched. We have been able to bring it down to its closest carbon atoms. You can see that here I wrote 4 carbon atoms before, 1, 2, 3, 4, which corresponds to boots. And now 1 carbon atom here at the extreme has been shortened, has been brought back to attach with the nearby carbon atom. Now, in this case, if you count the number of carbon atoms here, the total number of carbon atoms here, it is still 5 carbon atoms. And the total number of hydrogen atoms here is still the same here. All right, let's compare. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen atoms. Let's compare here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's still the same. The number of carbon atoms is still 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. You see the difference? This is the straight chain hydrocarbon, and this is the branch. 1 carbon atom here has been reduced and attach to its neighbor carbon atom. So that is what we mean by what? Branch. It is not necessary that you must branch the carbon atom and put it here. You can put it here. You can put it here as well. So when this is what we mean by a branched hydrocarbon. Now the straight chain, like I said, this one you can see there's nothing here. This one is just straight. The number of hydrogen atoms are arranged up and down. Straight. This is straight. While this one is what? Branched. Now, in the next series, I am going to be explaining this as well. In the upcoming series, I will be explaining this. You are going to be attaching this to this. So please keep following us. Then also, for the condensed, let me see use this. For the condensed, I am going to write the condensed structure for this, and I'm also going to write the condensed structure for what? This. Now, for this one, this is the condensed structure. This is carbon atom surrounded by 3 hydrogen atoms. This one. So we have this. See, how many carbon? 1. How many hydrogen atoms? 3. So we have CH3. We have the next carbon atom now. We have the next carbon atom. C. Surrounded by how many hydrogen atoms? 2 here. 2 is attaching. Then we have the next one. C surrounded by what? 2. The next one. C surrounded by what? 2. The next one. C surrounded by what? 3. Alright. Some people just write without doing this one. So we'll just write this correct. CH3, CH2, 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 CH3. So it's the same. Now look at this. This one, the condensed structure is going to be CH3. Then here you have CH. This one. Then you have the substituent here. Open the bracket. This substituent CH3 will be there. Keep following our videos. I will explain all this in subsequent videos. Then CH2, this one, then CH3. It's still the same. If you count the number of hydrogen and carbon atoms here, it is still the same thing here. Alright? But something has happened. Just something has happened here. Something has happened here. This is an isomer of this. Those of you that have learned about isomerism, this is an isomer of this butane. Isomer of pentane. So this is where I'll actually talk about. Don't forget that we have explained straight chain, branch chain, condensed structure, or hydrocarbons using the alkane series. We have been able to find the structure and the molecular for methane, propane, butane, and then pentane. Now, how that you student? I want you to get the structure, the molecular formula of hexane, octane, nonane, and decane, and also write their structures, possibly the straight, branched, and then condensed. Then in our next class, just make sure you do this and then snap it and drop it under the comment section. In our next, I'll review it in our next class. We are going to treat it. Now, let me also tell you that in our next series, we'll be looking at the alkenes series of the hydrocarbons specifically. Thank you so much. You can as well ask questions. Drop your questions in the comment section. We will do justice to it by answering it and also treating it in the next class. Thank you so much and God bless you.